With the quotient rule in hand, we can now get the derivatives of the rest of the trig functions. So our trig functions are going to cluster into two groups. The ones that have a co in front and the ones that don't have a co in front. If you have no co in front, you pick up no minus sign. If you have a co in front, you're going to pick up a minus sign. And then what's left over is you need to understand the pattern for each group. So let's start with the group that has no co in front. So that's sine, tangent, and secant. For each of these, there'll be no minus sign, so all you'll need to do is memorize the pattern for each individual. For instance, we already saw that the derivative of sine is cosine. If I do the derivative of tangent, I want to get a secant squared. If I do the derivative of secant, it's secant times tangent. So if I want to go over to the terms that have the co in front, it's going to be the same pattern, except you pick up a minus sign. If I take the derivative of cosine, it's going to be sine, pick up a minus sign. If I do the derivative of cotangent, well, I had secant squared before, so now I'm going to use cosecant squared, but I also have to pick up a minus sign. If I do the derivative of cosecant, I take a look at secant. That's going to be secant tangent, so I put the cos in. So its derivative is going to be cosecant times cotangent, but I have to pick up a minus sign. So those are the patterns that you need to remember to get your derivatives of all your trig functions. Okay, before I show you how you get the weird ones, let's take a look at an example of how we use it. All right, so as usual, I'm going to do a tangent line and then do an approximation. So what we want to do is we want to find the tangent line to cotangent of x at x equal to pi over 3. Once I have that, I want to get an approximation for cotangent at 1. So pi thirds, pi is roughly 3.14. So if I divide by 3, pi thirds is going to be close to 1. So we expect a decent approximation. All right, by our rules, derivative of cotangent is going to be cosecant squared. And since there's a co in front, I pick up a minus sign. So I have minus cosecant squared. Now, backing up a step, we're going to find the equation of a tangent line. So I write down the equation of a line first. We're going to need a point and a slope. Point's going to be given by taking our point pi thirds, putting it into our function. To get our slope, we're going to take the derivative, put our pi thirds in. That's going to give me the slope of my line. So let's take a look. If I put pi thirds into cotangent, okay, that's probably not right off the top of your head, but let's see how we pull that apart. So remember, cotangent, well, if tangent sine over cosine, cotangent's going to be 1 over that, which is going to be cosine over sine. So now I got to figure out what's happening with pi thirds. So I put pi thirds and pi 6 on the unit circle. We know the sine and cosine for both of those angles are going to be 1/2 square root of 3 over 2. Okay, and square root of 3 over 2 is roughly 0.86 or 0.87. So what happens? I want pi over thirds, which is the bigger angle. So that bigger angle is going to be higher, so that means that sine is going to be bigger. So the sine of pi thirds is going to be square root of 3 over 2. So the cosine is going to be 1/2. So if I do cosine over sine, I'm looking at 1/2 over square root of 3 over 2. So if I multiply top and bottom by 2, I get 1 over square root of 3. So that's going to be my point. Now we want to get the derivative, and then I want to put pi thirds into that. But what I just reasoned out before, our derivative of cotangent is going to be minus cosecant squared. Put pi thirds into that. Well, cosecant is going to be 1 over sine. So if I have 1 over cosecant squared, I'm looking at 1 over sine squared. We just saw that the sine is going to be the bigger number. It's square root of 3 over 2. So 1 over cosecant squared is going to give me 4 thirds. We have to put a minus sign in, so my slope is minus 4 thirds. I put them in to get my equation of a line. So my line equation is going to be y minus 1 over square root of 3 equals minus 4 thirds x minus pi thirds. To get an approximation, we stick a 1 in there. That's going to give me 1 over radical 3 minus 4 thirds, and then 1 minus pi over 3. You crunch that down with your calculator, and you're going to get 0.6403. If I put it into the actual function, or 1, cotangent of 1, we're going to get 0.6421. So we know our approximation's in the ballpark. So to show our rules, I'm going to pick one from each group, and the ones that I'll pick will illustrate the ones that we don't already know. So I'm only going to show 2 of them, although we really need to show 4. Let's start off with tangent. Take derivative of tangent. I can rewrite tangent as sine over cosine. So if I take derivative of sine over cosine, the territory that we're in is the quotient rule. So you want to hit this with your low d high less high d low over low squared, or you can just write things out in terms of the rule. So f is going to be sine of x, g is going to be cosine of x, f prime is cosine of x, and then g prime is minus sine of x. So we load those things into our rule. What's going to happen? You're getting cosines together, you're getting sines together, the minus sign in the numerator becomes a plus, and then you're dividing by cosine squared. What happens up on top? The whole thing collapses to a 1, so we have 1 over cosine squared, which is just secant squared. So that gets me my derivative of tangent. Okay, to get one from the other group, let's get the one that's like secant. So I'm going to do derivative of cosecant. What's going to happen here? Well, we have cosecant, which is 1 over sine. So we're in the case of the special case of the quotient rule where I have f equal to 1. So that rule says just take, if I have 1 over g minus g prime over g squared. So in this case, what are we going to do? Derivative of sine is cosine. So on the top, I have a minus cosine. Then we're going to divide by sine squared. So now it's just a matter of farming out that sine squared into 1 over sine. And then we'll also have cosine over sine and a minus sign out in front. So doing that, that's just going to give us a minus cosecant times cotangent. That's going to be our rule.